Good day. My name's Kerwin Stovall Williams, and first off, I'd like to say that I'm kind of passionate about this fire truck, and I didn't mean to come off so angry about it, but it's such a simple solution to so many problems. It just escapes me why it's not receiving any support. You're probably thinking maybe, I thought maybe that it's due to because of CO2 is a greenhouse gas or aerosol, not aerosol, but a hydrocarbon or what have you, and it might affect the ozone layer, but it's natural. Okay, we exhale it every day, and in fact, the employment of my device would actually reduce the amount of greenhouse gases exponentially, far below Elon Musk's uh, challenge for his emissions reduction. And how could he do that? Well, let's examine the average house fire or apartment fire or whatnot. Okay, there inside of every home there or residence or office or what have you, there are several. It's a mul. It's there are several different objects, multiple objects, and these objects are uh, composed of various chemical compounds, uh, plastics, carpets, the plexiglass, let's say the metals, and all of these are susceptible to degradation by heat and temperature. When this heat is added to a system, breaks down the chemical bonds, and thus giving you, since you have multiple ingredients, you have multiple hydrocarbons. So far more. Now let's let's go from there to we're putting this fire out with water. Okay, that's the conventional way to put out a fire. You're putting it out with water, and the response time for the fire department is under 3 minutes. So uh, they get there in 3 minutes. They got this blaze they got to deal with, and this blaze can continue for hours, utilizing the current methods. During that entire time, hydrocarbons are spewing into the atmosphere, just spewing, volcanically spewing. And in my research, this makes up the majority of the emissions that trying to deal with. We're trying to contain. Automobiles do the same thing. They burn a fuel, and the fuel is your furniture or gasoline or what have you, or whatever chemical compound, and then they spew these hydrocarbons into the atmosphere. Now, let's take a house fire and a car lot. Okay, now every time you turn these cars on, there's got a fire goes off, it starts in a home, and you got a whole car lot basically spewing. It's an equivalent. It's an equivalence. Okay, now in those during the hours, they're trying to contain this blaze. This is what's going on. Unknown hydrocarbons are being spewed. New chemical hydrocarbons are being made in this chemical reaction and going on in the fire. Okay, now let's examine the response time and extinguishing time of my mechanism, my fire truck. Now, I didn't even include the loss of life due to this archaic way of dealing with danger. Now let's move forward, shall we, as a race of beings. Okay, true, we're utilizing CO2 to extinguish the blaze, but what are the properties of CO2? It's heavier than air. So what happens? It goes into the building and pushes the oxygen out. The fire can't, the chemical reaction of a blaze requires oxygen. Now when this dry ice is introduced, oxygen is removed from the equation. Thus, fire is gone instantly. With the fire gone instantly, the smoke is gone instantly. Why? Because it's contained at lower temperatures. This is far below 32 degrees Celsius. So you're going to drop you're going to take a 400 degree environment all the way down to below zero, almost instantly. What effect does that have on the people in there? We breathe air. How are they going to survive? Will they survive a lot better on, you can breathe CO2 longer than you can breathe soot. Now, when you go unconscious as a result of smoke inhalation, you're basically dead. When you go unconscious due to low temperature and CO2, you're basically in stasis. Now, so when someone falls through the ice in a lake, they can be revived after 15, 30 minutes due to the fact of the cold temperature and no lung damage or brain damage. Now, the CO2 takes the smoke out of the air, so there's no lung damage. They just went unconscious prior to any damage occurring to the physical body. Thus, paramedics can revive them right as soon as they drag them out. And why can they revive them? Because as soon as they can drag them out, because the fire is gone in under 2 minutes. The response team has a visible line, a free line of sight, direct line of sight to any victim in the building or in the residence. That means they can get them out quicker. Now, why do I say use? I believe in prevention is worth, an ounce of prevention is worth a pound of cure. Now, currently, after a house fire, the cleaning, you put it out with water and you got all this water damage and smoke damage all through the residence. How do they clean that up? They go in with dry ice cleaners and they dry ice blast the soot off the damage. Now, why would you go in after the fire when you could have prevented the damage, prevented the loss of life, and also reduce the amount of hydrocarbons going into the atmosphere? If you're not having to spend hours or days at a fire trying to extinguish it, then the amount of hydrocarbons in that event is lowered due to time at the event. It's literally elementary. That's why I'm so angry. Those lives are on you.